Hi, my name is Greg. I'm an atheist. I post as GKLR here on YouTube. And this reply is going to be to M. Williams, or Mike, with his well-proposed reply to my first video here, arguing how atheism is a belief in rather than a lack of belief or an absence of belief, where I called atheists parrots for being just parroting. What I've done, or what I've decided to do, is we're going to look at what Mike has written out on his paper, and it's in this video it won't be me. We'll look at the piece of paper, and Mike will be talking. I've captured the audio, and I've got Mike's permission first, which is something that I haven't done before. But I just wanted to clear that up. I'm sure the screen capture is publicly available, but I think the audio can be copyrighted. I don't know. In any case, I was going to make a good video, I think, because, or at least from my perspective, because I'll be able to overlook what he's done, pipe in my 2 cents, maybe add some graphics of my own, and sort of get out, the other side of what's trying to be said, rather than what it seems that Mike's interpreted that it is being said. So we'll do that, and so I'll be overlooking the piece of paper the same way Mike was, and sort of talking almost like we were side by side. Now I'll be able to interject when Mike is talking, and I'll stop him from talking, and I'll just interject for what I have to say. And I don't think that, of course, I'll be able to do that for Mike because I don't have him right beside me here. So other than that, we're going to do this, and hopefully it's interesting. So here comes the picture, and I'll try to edit some of that too. Okay, so here we've got Mike's picture, and he's using U as the set of all animals. He's using H as those animals with horns. He's using AH as those animals without horns. And he's using X star as a member of the set of animals with no horns. Essentially, that's what he's done. I'm going to let him explain it as he goes through as well. And I'm also going to add my own graphics to this and highlight the graphics that Mike's talking about and that I'm talking about as we go through. Okay, so next voice will be Mike introducing U and H, which would be U is the set of all animals, H is the animals with horns.
First off, I want to talk about this idea of animals with horns, and I'll start to do that by drawing first the universal set, and I'll call it U, of all animals. Now, we know that there are some animals that have horns, so we'll represent the set of animals with horns as some subset of U, and we'll call it H. So this is the set, then, H, of all animals with horns. And if I wanted to write down what H was, I would write something like H is the set of all X that are elements of U, such that X has horns. So this to me defines H very well, although mathematically has horns is something you might have trouble defining, but anyway,
Okay, before I get started, I wanted to thank Mike for his effort here. I think that the more that people were able to outline their ideas like this, then the better off we would all be, because we would see what people are saying. Up till now, the statement certainly that I've underlined here in red, is something that's agreeable. There's no real problem with this, accepting that X has horns. As he says, that it's difficult to prove this mathematically. More so, it's something that we couldn't deal with. In set theory, we want to deal with hornness, and this might seem minor for now, and it is, but it's one of those things where when we're dealing with horns, and so part of the problem of what Mike has done here is that he's actually crossing over 2 fields of study. One is formal logic and one is set theory. So set theory is where we're going to be using, what he's done here is create sets and subsets, and talked about members of a set and stuff like that. So that's set theory, and when we use the operator not, that this isn't something we do with set theory. In set theory we use non, as well as he's using members of sets and subsets as propositions, which is a part of logic, which isn't used in set theory. And so I'm going to go through this, and the reason why that this understanding, as well as how this addresses my argument, not just the problems in between these 2 fields of study, but is the what I'll be doing is addressing how this affects my argument as well as what he's trying to say in terms of what he's actually trying to argue, rather than and what is meant, rather than just these types of errors. So has horns is as Mike says, it's something you would have difficulty defining mathematically, and in fact we're talking about hornness, and that's because of how it's applied in set theory. So we'll move on here. That's the next statement where we begin to really cross over things and find a problem. So let's continue to listen to Mike.
And I can proceed then to define another set called, let's call it AH, and I'll define it using the logical negation operator on H. So now I've represented both H and not H.
So at this point in the video, Mike has used the logical operator not to negate a set, and this isn't done. There is no not in set theory. To negate a set in set theory, it's done with a non. So we would say H and AH would be non-H rather than not H. So not applies to propositions and properties. An example, we could say like a proposition, something is true or not true, and we could say something is red or not red. But we couldn't say something is not Mike. In other words, it doesn't refer to an object. When we say not Mike, we have nothing that we are referring to. So there's no such thing. In terms of set theory, we would refer to non-Mikeness or non-redness. Something could be in logic. We would talk about something is red or something is not red. In set theory, it's talk about something would be in a set of those things with redness or non-redness, not redness. In the same way that I wouldn't say my car is redness, I say my car is red. So in the same way that we would have a linguistic issue with saying that my car is redness, is saying not H in this way. It's non-H in set theory. So not doesn't apply.
AH is what H is not.
So here again we're seeing a demonstration of the confusion between formal logic and set theory, where in set theory there is no not. So this is a nonsensical statement in set theory to say not H. It's non-H as the way it would be properly represented in set theory. Not, again, applies to propositions or properties. So a set is not a proposition, and it can't be treated like a or a member of a set is not a proposition, it can't be treated like a proposition. They don't have truth value, so you can't attribute a truth value to a set or to a member of a set.
And I can even add as opposed to a statement such as AH is not AH, which would be a contradiction. So this would represent a contradiction. That's how I'll write contradiction.
Okay, I think I've established that in set theory that there is no not. And so the way that this would properly be represented would be, of course, it would be AH is non-H, okay, rather than not H. And as well as when he gets to AH, he says as opposed to AH is not AH. It's something, again, wouldn't be said in set theory. It's something that's a proposition in itself. It's also not a contradiction. What a contradiction is P and not P at the same time. So AH is not AH is a proposition, not something that can be said in set theory. It's something that is a proposition itself, and it is not a contradiction. It's false. It's not a contradiction. It's like saying 1 and 1 equals 49. That's not a contradiction. It contradicts what mathematics says, but it's not a contradiction. It's false. So AH is not AH is simply 1P. You would need a P and a not P to make a contradiction, whereas AH is not AH is simply a proposition. And AH, if we tried to turn it to like P and not P, if we said AH and not AH, is also not a contradiction because AH is not a proposition. It's a set without a truth value. In other words, there's no truth or false to AH. So this is why even AH and not AH is not a contradiction, whereas P and not P is a contradiction because it's a proposition and has a truth value.